Hello, everyone. Welcome to Chemistry 100 with Professor John Nguyen. I would like to go over the homework for Chapter 1 quickly. And this is the answer key that I post on the website. I would like you to try them first, of course, before you look at the answer key. Um, Make sure you understand how to set up. Again, it's as I always mention, it's always good to know what we need, so that way it's easy, make it easy for us to know where to get started. Okay. For example, the first one, a person height is measured to be 5'10", which is right at 70 inches. What is this height in centimeters? So the exercise want us to convert inches to centimeters. What we need is the conversions from inch to centimeters, and it's given here. That's 1 inch equal to 2.54 centimeters. We should know that. Okay, so we always start out with what we given. In this case, it is 70 inches, 70.0. Notice that it has three significant figures. So keep that in mind. Our final answer must also have three significant figures to be consistent with what's given. And ignore the conversions. Okay, that's the easiest way. Now, one inch equal to 2.54 centimeter, and you want 2.54 centimeter to be on the numerators because you want to cancel out the inch to get the centimeters. If you take the calculator, take 70 multiplied by 2.54 and round it off, you should get 178. Remember, if it's 5 or more, you round the previous number up. If it's 4 or less, just completely dropped it. All right. Now, for number 2, okay, this one we gotta think about a little bit. A gas exactly fill a container previously determined to have a volume of 1.65 liters. So we got the volume. That's the empty container. Now, the container plus gas are weighed and found to have a mass of 638.6 grams. So we got the mass of the container and the gas. Now the container itself, when empty, it has a mass of 635.2. So notice that we got mass of the container with and without. If you subtract, obviously the larger one, subtract the smaller quantity, give you the difference, and that's the mass of the gas. The problem also gives us the volume. Notice that the volume of the container is also the volume of the gas, because when you put the gas in the container, the gas will take up the whole space. Okay? And you got the mass, you got the volume. We can calculate the density. And it even gives us a good hint right there, the density in gram per liters. So you take 3.4 gram divided by 1.65 liters. Now both of these quantities are from the problems are given, or we figure it out. Now they are not conversions, therefore they have definite number of significant figures. 3.4 has two significant figures, 1.65 has three, so by the rule we have to follow the limited one, which is 2. Okay, so your final answer should be routed to two significant figures. Now if you do the math, you take 3.4, you divide it by 1.65, you should get 2.06. Okay, 2.06 if you have a calculator. and we cannot keep it 2.06. That would make it a 3 significant figures. So you need to route it off to 2.1 because it's a 6. So the 0 becomes 1. Okay. Okay, for number 3, our job is to be able to identify and count how many significant figures, how many numbers are important in each of the following quantity. Okay. For example, the first one is 0.404.0030. Now we count everything because starting from the 4 all the way to the right, that's because of the decimal point. Now the 0 in front of number 4 has no value, okay, and no precision either, okay, so we don't have to count that one. Therefore, it has 5 significant figures. Now, the second one, all these 0 on the left side, we don't count them, even though there's a decimal point. These zeros are placeholder. You got 1, 2, 3, 4. You can convert this into scientific notations, and you don't have to use those 0 at all. And that would be 1, 2, 3, 4, and one more to get to the 1 point something. Okay, and that would be 1.910 times 10 to the minus 5. So you would not have to use any of these 0 numbers. Okay, therefore they're not significant. You can replace them. Okay, therefore we only have 4 significant figures here. Now this last 0 is significant because it's a decimal place. Okay, it tells us the precisions. All right, we cannot replace that. Okay, for C, whenever you have a scientific notation, you only look at the base numbers, which is 1.030, because you start with 1, that's a non-zero, everything else basically locked up. So we count everything else for quantity and also precisions. The last 0 is strictly for precisions. Okay, so therefore it has 4. And 2500, if you just say 2500, that's only 2 significant figures. Only the number 2 and number 5 are meaningful. The rest are estimate. Okay, but here because you have decimal place, so it means precisions. You want it exactly 2500.00, whatever you measure. Okay, so all of them are significant figures. Therefore, we have 6. All right, that's number 3. Now, number 4, it's about conversions. Converting 4,540 milligram to kilograms. Notice that this number has only 3 significant figures because there's no decimal point. And that last 0, okay, that last 0 doesn't count because we can replace that. Okay, if we do scientific notations, we wouldn't need that 0. Okay, so let's convert it to, so keep that in mind. You will have only 3 significant figures by the time you finish. All right, now milligram. What do we need to go from milligram to kilogram? Now there's no direct conversions. Milligram, we know that 1 gram is 1,000 milligram. Okay, and we know 1 kilogram. Kilo mean 1,000 gram. These are very popular conversions. Okay, so here we go. We're gonna go from milligram to gram. 1 gram over 1,000 milligrams. So we cancel out milligram. And then from gram, we convert to kilogram. So it's a 2-step conversions. 1 kilogram over 1,000 gram. Cancel out the gram. We get 4.54 times 10 to the minus 3 kilogram. So we write them in, we write the answer in scientific notations, okay, as requested here. All right. Now, next, we got 15.0 10 to minus 8 meters, and the conversions is 10 to the 12 picometers over 1 meters. You can use either one, okay? If you use 1 picometer on the top, you want to put 10 to minus 12 meters on the denominator, that's fine. And when you divide it by a negative exponent, it will become positive, okay? But if you use a calculator, the calculator will take care of that, okay? And so you should get, if you do by hand like I did here, I take minus 8 and plus 12, okay? Because they both on the top. Minus 8 plus 12, that's going to be 4, and 15 is 10 to the 1 power, okay? So that's add another power exponents, add another 1, that make it a 1.50, 10 to the 5th power picometers. Now you can do all this in a calculator as well, okay? Next, we got 3.4 times 10 to the minus 12 meter to centimeters. Okay, it's a one-step conversion. We do have 100 centimeters in the meters. 100 is the same as 10 to the second power. So in the calculator, it's a good idea to put parentheses. That's going to be a good habit. It doesn't make any change when you have the number in the, when you multiply or on the numerators, but it does make mistake if you if you divide by exponents and you forget to put parentheses, okay? It all depends on the calculator, but it's always safe to put parentheses on. I'm talking about in your calculators, okay, when you input the number in the calculator. So if you do this setup, you cancel out a meter, you multiply using the calculator, or you do by hand as I show right here. You got 3.4 minus 12 plus 2, that give you minus 10, okay? Milliliter to liters, 4.8, okay? We know one liter equal to 1,000. 1,000 is the same as 10 to the third power milliliter. Cancel out a liter, milliliter, and when you divide, you subtract. So it's minus 4, subtract minus 3. So minus 4 minus 3, and make it a minus 7. Okay, now next we got 7.23 10 to the 4 gram to kilogram. Okay, 1 kilogram over 1,000 gram. So that way we can cancel out a gram. 1,000 is written as 10 to the 3 power. And now divide means subtract the exponents. So you get 7.23, 4 minus 3. Divide means subtract. If you subtract a negative numbers, it becomes positive. Okay, but in this case, it's positive. Okay, so you got 7.23 10 to the 1. All right, so those are unit conversion. That's main big topic for chapter 1. More conversions. These are the temperature conversions. Okay, so for chapter 1, unit conversions, temperature conversions, density, and heat calculation. Those are the key topics, the key concept and skill that we need to be able to do, okay? Temperature conversion, there's a formulas for every conversions. When you go from Celsius to Fahrenheit, it's said right here, the formula. You take temperature in Celsius, multiply it by 1.8, put it in parentheses. If you don't do, the calculator will figure it out, but it's good to do, plus 32. That's the fixed number, 32. Okay, so if we take 1.8 times 85 plus 32, we should end up with 185. Okay, now when you go from K to Celsius, all you have to do is subtract 273.15. Now this is a whole number, so 0.15, that's not going to make any difference. So we got 185.85, and we need to round it off to whole numbers because we start out with whole numbers, and that would be 186. Okay, so and as I mentioned, heat topic is one of the major concepts, okay, that we need to know. Well, this exercise uh, is about calculating total heat amount needed to heat up the water to boiling temperature, which is 100 degrees Celsius. The formula is um, heat, which is Q, equal to M times C times delta T. And notice that I write the formula on the corner on the side, so that way when you look at the problem quickly, you know what you need. You need that formula, okay? Recognize what type of questions and what's asked and what you need. I think that's important. Um, First step to solve the problems. Okay, now let's plug it in. And mass, we got it, 525 times specific heat is C, given 4.184. Notice I put in the unit, so that way it give us the guide, and to make sure the units cancel out. Temperature difference, this is important. When you heat the water from 24 degree to boiling, which is 100, the difference, you always take the final temperature, 100, minus initial, which is 24. And that gives you the difference, which should be 76. Okay, so you take 525 times 4.184 times 76, you should get 166,942. But if you look at this, 76, that's only two significant figures. We're limited by that. So we need to round it off, and scientific notation is the best way in this case. 1, 2, 3, 4, 5 to the left. It's a large number, so it has to be positive, positive 5 exponents. And it becomes 1.66, so we round it off to 1.7 joule. Okay. You can also convert it to kilojoule if you want. Okay. And in this case, similar questions. And you got the mass, same formula again, times C is given. Gram cancel out, Celsius cancel out, end up with joule. That's exactly what we're looking for. Going from 22 to 65, 65 minus 22, give us the difference in temperature. Take that, multiply it by 4.184, multiply it by 12.65. You should get 2276. Write that in scientific notations. So you got 10 to the 3, and you round it up. The 7 become the 8 because that's a 6. That's 5 or more. Okay? So when you're not sure how to express with the correct significant figures, convert the number to scientific notations. That make it a lot easier. Okay? Okay, number 9 is about density. Density is defined as mass divided by volume. We are given mass 129 gram. We are given volume of 125 milliliters. Simply divide and keep everything in three significant figures, 1.03, and we should be good. Okay. And finally, number 10 for this chapter 1. Number 10 is related to heat again. Now, it takes 91.6 joule of heat to raise the temperature of 51.9 gram of a metal by 4.1 degrees Celsius. Okay, so you only get one temperature by 4.1. You can tell that is the change in temperature, the subtractions. Final temperature minus initial temperature is already done for you. That's delta T. Okay, so you have to be able to recognize that. Okay, if you're given two temperature, you take the second one, you minus the first one, and you get the delta T. But here it's already done for you, so that's nice. The formula is heat equal to M times C times delta T. Now, if you rearrange C, if you want to find C, you have to divide both sides by M and delta T. And that's why M and delta T end up on the denominators. Okay. And plug everything in, 91.6, that's given. Mass, 51.9 times 4.1. Remember, if you use a calculator, you must put parentheses. I multiply them together. I got the numbers, the bottom one, and then I take 91.6, I divide it by that, just to be sure. If you do this without parentheses, the calculator will make the mistake. It will divide it by 51.9 and then it multiplied it by 4.1, which is wrong. Okay, it should divide by altogether at the bottoms, which is 212.79. So if you do as I show here, you should get 0.43 ram per joule per ram degree Celsius, which is the correct answer. All right, that's it for Chapter 1 homework, everyone. And of course, we also have additional practice. And on the next video, we'll go over Chapter 2, study guide, a lecture, example, and then we'll do the same. We'll go over the homework as well. Thank you, everyone, and have a good day, and hope to see you again in the next video.